So target 4 promises to not use any passwords encoded in the executable, but instead has the lock itself contain the password and do the password validation. So is that correct? I don't know. Let's take a look at check password. So as we scroll down through here, we see it prompting. And when it's done with the prompting, it jumps to 4011 BC. And here's the other prompt. And so after that should be 4011 BC, which is correct. And then it takes the password and it puts it in RDI and calls validate password. So, and let's just see what it does after that. It compares the return result in x86-64. The return value from a function is stored in EAX, so it's comparing that with 1. And if validate password returns 1, it stores 1 in a variable that's stored just right at the bottom of the stack frame, and then it jumps to E3, 4011 E3, which takes that variable that it just stored and puts it in EAX, so that's the return value of this function. So let's look at validate password and see if it's got anything that looks curious. So it does its stack stuff. It's calling write. Let's see. It puts 1 in EDX and RAS. There's a pointer in RSI, which, yeah, that's the pointer to the data. So let me see. 1 is the length. The third parameter is 1. And there's a pointer, and then 1 is also the first parameter. So that's calling, it's writing something to standard out. File descriptor 1. Calling write, and then that's probably the password. It's putting that in RDI, calling strlen, and I'm guessing it's calling write. So I think it's writing to standard out the password, and it uses strlen to find out how many characters are in the password. And then it's calling read, and let's see, EDI is the first parameter, so it's reading from standard in, and this is probably the pointer to variable of some sort. Yeah. So RAX has a variable that's just at the bottom of the stack frame, and then it's reading 1 character. So it reads 1 character, and then takes that variable and sticks it in EAX, and that's the return value. So, so validate password is communicating essentially outside of itself. So I don't think we can exploit that very easily. But let's go back to check password. Oh, actually, let's look at main just to make sure. So it calls check password, and if check password returns a, let's see, compare testing EAX. If it's equal to 0, it jumps down to 1132. If it's not equal to 0, it will continue here, and it will call open lock. So as long as check password returns a non-zero value, it should still open the lock. So how do we get check password to return a non-zero value? Let's go back and look at it. And let's go ahead down to where it calls validate password and see if there's anything after that to begin with. Because I don't think we can do anything. We don't know what the password is. I don't think we have a way to find it. So one thing that looks promising here is this variable, because if the password's valid, it sticks a 1 in the variable, and then we saw when it in 4011 E3 it loads that variable, and that's the return value of this function. So if there was a way to set that, then we could make it still return 1. Now, the reason I bring that one up is that this may be ripe for a buffer overflow. So if you go back and look, remember that in all the other times, and it looks like in this time too, the password is stored at hex 20 locations above RBP. And this variable that we're storing the 1 in is just 1 before RBP, which means that in the layout in memory, the buffer where the password is stored comes before that variable. So if we are allowed to type in enough characters in the password to overwrite that variable, then maybe we can set it to 1. So this is hex 20 is 32 in decimal, and so 32. If we entered 32 characters, that would go all the way down to RBP. So we really just need 31 characters. So let's try that. Let's see what happens. Let me put a breakpoint right after prompt finishes. So this right here. So before we validate the password, I'm going to set a breakpoint, and then I'm going to hit continue. And now I said 31 characters, so I'm going to number them. Okay, so that's the first 10. That's the second 10. That's the third 10. So this is character 31. So let's hit enter, and we are at the breakpoint. Now what I want to see over here is I'm going to look at the stack, and let's see. RBP, I think I didn't hit enough characters because RBP is set to FFFFD030, which is right here, and this is where on the stack, this is where the old stack pointer, and actually what I really want is I want this. What I want is, I think RBP -1, so this value needs to be non-zero. So I'm going to hit continue. It's probably going to say the unlock failed, which is what I expected. And I'm going to hit continue. And now I'm going to do the second 10, third 10. Okay, and now 0, 1. It's okay because these are not hex, so 0, 1 is 30 in decimal. What is that? Oh, that's 48 and 49 decimal. So if I hit enter, the unlock succeeded. So let's go back and look at that again just to see what I did. So if I go to check password, and and the reason that we didn't hit the breakpoint, no. We'll go back to where it's calling validate password. I'm going to put a breakpoint there, and I'm going to hit continue, and I'm going to go, yes, I know what, I have a complete explanation for this now. I'm starting the third 10, okay, and 0, 1, so 32 characters, and I hit enter. I hit tab, and so you can see we're broken there at validate password. And when I go over here and hit S to see the stack, I can see that I do in fact have the RBP is at DO30, so RBP -1 has a 31 in it, and so let's step through this and watch what happens. So EAX returns 0 because validate password says that's not the right password. And so it is, they are not equal, so it's going to jump down here to D3. Now it's going to add 1 to the variable that is how many times have I how many times have I tried the password. And you see that is at hex 8 relative to RBP. And so I overwrote that too, because that would be 1, 2, 3, 4, 5, 6, 7, 8 right here at D028. And so that number is now really big. And it's also now comparing that variable that I've overwritten the flag with 0. And so it's going to say that is not equal to 0. And so it's going to make it jump and return. It's going to put that variable in EAX. So you can see that RAX, which is the 64-bit version of EAX, now has 31, which was this last character here. And so it, I'll keep stepping. The unlock succeeded. And we're done. So that was a simple buffer overflow that didn't, it just modified a variable on the stack. There are ways that sometimes this will work and sometimes it doesn't. It depends on if the variable is below the buffer that can be overflowed or above it in memory. And we were just fortunate that it was below the buffer in memory, or above it in memory, so that as the buffer overflowed and kept writing into memory, it overwrote that flag. So maybe buffer overflows are going to be the way to exploit the other targets. We'll have to see.